on the denominator. What can x never equal in this case then?
0.
That's where our ass gets involved. These are called asymptotes. Asymptotes means that your graph will never touch it.
Touch what?
Your asymptotes. Never touch asymptotes. Yeah, come on in.
Alright.
Dorf's going to help us, ladies and gentlemen. You're going to be on the blog right now. Okay, we're talking about asymptotes.
Okay.
Do not touch asymptotes.
What doesn't touch?
Your picture, your graph,
The graph doesn't
your
touch.
values. It will never touch. Think about it.
Zero.
X cannot be 0, correct?
So it's imaginary?
So your asymptote is what?
Well, we're going to show you.
Is an
I'm going to
asymptote
show you what an
something
asymptote looks like.
I'm confused.
Patience, my friend.
Should we have different colors for this?
You do it. Yes.
Okay.
All right. So, ladies and gentlemen, asymptotes are represented with, you're going to have a vertical asymptote and you're going to have a horizontal asymptote. Vertical asymptotes we will show with a dotted line. That just shows, hey, there's your asymptotes. Okay, so x cannot equal 0. Does everybody agree and understand why there's no way you can have 0 in the denominator? Correct. What else are you going to know here? Remember, f of x is the same. For some of you, do better with y equals. What will y never equal? There's where your asymptotes are. Remember, if you can't touch it, you can't equal it.
Because it's 0 and it's not there, so you can't touch it.
Can't touch it. That means that x will never equal 0. It's impossible. What will y never equal?
0.
0. Why? But why? We're going to have I agree. You're going to have another asymptote, a horizontal one, at 0. Yes. But why do I know that? Well, can you take 1 divided by some number and get 0? Ever? It's impossible. It's impossible. Now, those of you that are memorizers and shortcutters, what you will find out is take the denominator here for your horizontal asymptote, vertical asymptote. Take the denominator and set it equal to 0 and solve it. That'll give you your vertical asymptote every single time.
I heard it can't be 0.
What? Asymptote, vertical asymptote. That's telling us where we are going to have our vertical asymptote, therefore it cannot touch that. You will not have an x value. Be patient with me. Now, what these pictures come out to be are called hyperbolas. Hyperbolas will take up 2 quadrants. Remember your quadrants, 1, 2, 3, 4? Okay? I will call these symmetrical, and then these are symmetrical. Symmetrical means it's going to be the same on both sides. Okay? Now, in this case, let's think about what it's going to look like. What is this going to look like? So we'll make just a quick T-chart. X and Y. If I say that X is 5, what's Y? 1/5. If I say that x is 1, what's y? 1. If I say x is -1, what's y? -1. If I say x is -5, -1/5. Okay? So, 5 and 1/5 would be about there. 1 would be about there. -1, -5, 1/5. Approximate it. It does not have to be perfect. Now, let's think about what my hyperbola is going to look like. What's my picture going to look like? Remember, I can never cross this. You won't cross it. You ever play Pac-Man? Where you go off the screen and then you come in the other side? That's kind of what hyperbolas do. This one's going to go here forever and ever, but never touch that horizontal asymptote. Where's it going to come back in? The other side.
So can we get like a definition for that?
The definition for what?
Hyperbola.
I'm drawing it. It's a visual
You can't
picture.
put it-
It's just like a parabola. I can't.
So can I put
I can
back
show
in?
you. Sure, if you want. If it makes you smile, that's what I'm about. So the red. Notice hyperbolas never touch these asymptotes. They'll never cross them. That's what it means. Yeah.
So asymptotes is like another word for just axes or what?
Don't get confused because those asymptotes are going to move.
What are asymptotes though? Like, what are they?
They're spaces or vertical or horizontal spaces that your picture will never cross. So in other words,
So like
X will never be 0. Do you agree with that? Okay, so if X is 0, that means that it's going to be on this horizontal line. Well, it never touches it.
Okay.
So it's an area of a line that we'll never cross.
So is
Ever.
it like that? Like, would it be an area we shade?
There is no shading here. Remember, shading only deals with inequalities.
Okay.
Okay? Be patient. It'll keep coming. It'll keep coming. Now, ladies and gentlemen, let me give you some shortcuts or things to look for that will help you graph this a lot quicker. Because who wants to make a T-chart?
Nobody.
Nobody. We got graphing calculators. We can put those in. But I'd like for you to be able to predict. I'm big on predicting. What's my picture going to look like before I type it in my calculator? So, symmetrical. That means that if I draw one here, guess what? I'm going to have that exact same picture in its kissing quadrant. Let's call it kissing quadrants. Vertical angles. Paige, you know about that, don't you? The different quadrants. Okay, good. And this is a hyperbola. Hyperbola will have some asymptotes in it. Okay, so we've had some different pictures that we've kind of known about: square roots, cube roots. We've done quadratics. Now we're doing hyperbolas, which will be with rational functions. Rational functions means shortcut, small definition is you're going to have some letters in the denominator. All right, identify your A value. Identify your A value. In this case, my A value is 1. It's going to be on top. In this case, when we come over here, my A value is 3. Okay, my A value is -4. Okay, so it's going to be on top. It's going to be the first coefficient. All right, Paige?
So, for those,
Yeah.
is that like different ways we write it?
This is going to be different types of rational functions that you're going to see.
Like, are there names for them?
I don't have specific names. We can call them Paige.
Well, no, I just
And
didn't know
Turna.
because like the joint and the whatever.
I don't have a good answer for you there.
Okay.
Yeah, that's a great
So just,
question.
like, know 'em?
But let's just call this one Simple, Paige, and Turna. Okay? Or should we go Turna Paige?
I don't care.
Okay. All right. Well, we'll figure it out. Now, if your A value is positive, remember the quadrants. 1, 2, 3, and 4. If it's positive, your hyperbola is going to take place in 1 and 3. Now, understand that you might have your asymptote here and here, because we do have some transformations that can go on. If that happens, still, there's 1 and 3. So it's still your upper right corner, if you want to look at it that way, and lower left, if A is positive. If A is negative, guess what?
The other two.
The other two. Bernie, you are on fire. You must have a weekend at Bernie's coming up, huh?
I had some Wheaties this morning.
What? Oh, Wheaties. I thought he said weed too. Had some weed this morning. Great job. Now, if A is a really small number, now it's real tough to see, but this is 1, 1, and A was 1, correct? If it's smaller, it's going to get tighter to that origin or to those asymptotes. If it's larger than 1, it's bigger, it's going to be a little bit further away. So, bigger, we might be out here. I better not dot it, huh?
Wait to rewrite this.
So,
And if it's less than, we might be in here.
then would one of the coordinates have to be like 0.5, 0.5?
Yeah. You'd have some weird numbers. But, again, what's my big thing? Predicting what it's going to look like. Is it going to be kind of far away? Is it going to be close? What quadrants are we going to be hyperboling in? Okay, now the toughest question that people run into is finding their asymptotes. It's the toughest part. Because once we get our asymptotes, can't you identify kind of what your hyperbola is going to look like? Well, let's take a look here. This is the Terna rational function. Yeah, Terna. And this is the Page function. Terna. Like Terna.
Like turn up?
No, turn A. Okay, so here's your asymptotes right here. So anything that's added on, do you remember those add-ons that we had with our square root functions, our cube root functions, our vertex form functions? The k value added on the end is going to be your horizontal asymptote. If you have, remember, what's the other way? This says x equals h for your vertical. If you can't remember that, just take the denominator and set it equal to 0. So let's take a look. Where are my asymptotes? Let's start with the vertical. Vertical is x equals or y equals? No. X equals. X equals. Where's my vertical asymptote here? Alex, where is it? Close. Negative 2. Why negative 2? What's negative 2 plus 2? 0. Can you have a 0 denominator? No. Therefore, x can never equal negative 2. There's my vertical asymptote. There's one of them. Where's my horizontal asymptote?
Wouldn't it be?
Negative 1, exactly. It's your k value. Y equals k, your horizontal. So, I'm going to draw a dotted line to represent that I am not going to touch those. Is my a value positive or negative?
Negative.
It is negative. My a value is negative 4. Which two quadrants? Let's start with which quadrant, right or left?
These two.
So,
Oh, this is all we have to do.
yes.
Get the quadrants.
That's not even that hard.
I know.
Do we, okay, will we be given the y equals
Yes.
whatever?
This is what I will give you. I'll
all
have
we
you
have to do?
sketch it.
How did you figure out?
It'll get more complicated as
What are you doing?
No,
You spit on
it doesn't.
Then how do we do
Stop
it for
it.
that
yeah,
top
first then.
one?
I thought you
That's
said
where I'm going to next.
I thought you said x could equal negative.
That's why. we draw
That's why it
above
doesn't cross negative 2.
So pretty much all we're trying to do.
If it was
It's
where the asymptote is, yeah.
all we're looking for is the asymptote.
Find the asymptote, find your a value.
5. No. Stop it.
Here we go. Here's the page format. Doesn't it look cute?
Just like Paige.
3x plus 3. Number 1, let's start with the vertical asymptote. Vertical asymptote. No 0 but. What causes us to have a 0 denominator? 3. There is my vertical asymptote. So I have a vertical asymptote at 3. I've drawn it. Now, here's the first curveball. There's nothing added on at the end, is there?
Yeah.
Here's the first curveball. Are you ready? To find your horizontal when it's in the page form. To find the horizontal, it's going to be y equals, and you are going to take the a value divided by the c value. That will give you your horizontal asymptote. So in this case, a divided by c, 3 divided by 1. So I will have another asymptote where? Exactly, 3. Let's do it this way. A over c. A is 3. C is 1. So, a value positive or negative? A value positive or negative? Positive. Am I going to be far away from this intersection or really close?
Close.
Well, I'm going to have to disagree.
Far?
This it's kind of away from the asymptote.
I can say pretty far.
Yeah, that was a good idea. And we're in quadrants.
Just like this.
Top right.
1 and 40.
Is this perfect? Absolutely not, but it's pretty darn close.
What do you mean? Is it perfect?
What do you mean, like, if there's something added on to the end, like the +3 and the minus?
Outside this fraction, like plus, then you would have, here when we come over here, we have the -1.
It's just so you don't like
That's automatic, your horizontal asymptote.
equal to or not equal to.
And the nice thing is, what I would like for you to do is try to guess what it's going to look like, then type it in the calculator. I know you can put it in your calculator this weekend and then copy it off your calculator screen. Write down, even if I said, hey, put some points so I know. I mean, I know you can do that. I want you to be able to kind of guess what it's going to look like and then type it in.
On a quiz or test, will we be able to use our calculator?
Absolutely. I'm a calculator fiend.
Okay.
So, those of you that have graphing calculators are going, well, I don't care what, I'll just type it in. Again, predict. Don't you like to kind of know what's going on, what's going to happen? When you go on a date, don't you kind of have an idea of what's going to happen? Keep it sane, Bronk. You kind of have an idea. So, that's what we want here. All right?
How do you